In last lecture, we had seen the relationship between pointer and a one-dimensional array and how a pointer having a starting address of an array can be used to access all the elements of that array. In this lecture, we will see the relationship between pointer and a two-dimensional array. So let us consider the declaration int b of 3 3. So b is an array which has 3 rows and 3 columns, and it is initialized with 1 2 3 in the first row and 5 6 7 in the second row and 8 9 10 in the third row. Now b is considered as an array of arrays. Like within this array there is an array 1 2 3 and an array 5 6 7 and an array 8 9 10. Now what exactly b contains? So as we know that in a single dimensional array, int a of 5, a contains the starting address of the array. Here also b contains the starting address, but b, what actually b refers to? B actually is a pointer to a first row. It contains the starting address of this two-dimensional array, but it is actually a pointer to the first row. That is one of the reasons why we need to specify uh, the uh, the number of columns when we declare an array. It is compulsory. So when we do b plus 1, what happens is, as it is a pointer to the first row, when we do b plus 1, it will point to the second row first element, and when you do b plus 2, it will point to the first element of the third row. Now we can check that by running. So we are printing b and b plus 1 and b plus 2. So here there are 3 integers, each of size 4 bytes. So starting address of the first row and plus 12 gives the starting address of the second row. Plus 12 gives the starting address of the third row. And then we can check that. And when we run this, you can see here 80 is in hexadecimal representation. 80 and 80C, C is 12. So 80C and then 98. After 80C, D, E, F, we'll get, so 8 plus 4, 12. So now the interpretation of B is a pointer to the first row of an array. Now what is star B? Star B is the now pointer to the first element of the first row. And when you do star B plus 1, it points to the second element of the first row element, because B is referring to the first row. And when we do star B plus 1, it will point to the second element of the first row. So we can check that by running. Similarly, star B plus 2. You can see here 20, 24 and 28. So the starting address of this, the first row is 20, and second element is at 24 and the third element is at 28. Okay. Now how exactly this, suppose when we say b of 1 1, how exactly it is interpreted by the compiler? So as we know, b is a pointer to the first row, and if you do b plus 1, because we are interested in here the second row first element, so b plus 1 gives the b plus 1 gives a pointer to the second row. Now if I do star, now it is a pointer pointing to the first element of the second row. And if you do one more plus 1, now it is a pointer pointing to the second element of the first row. And if you do one more star, it gets the value from that location, dereferencing. So this is how it is interpreted when we write b of 1 1. So now we can check by printing printf percentage d so run it gcc, oh, sorry, comma is semicolon is missing, so just run it gcc, and then so when you run it you are going to get a 6. Second row first element is 6. Similarly, suppose if I do here b plus 2, what happens? So b is referring to the first row. B plus 2 means now it is pointing to the third row. In third row, and when we are doing here plus 1, we are referring to the second element. So it should give 9. Yes. Okay. Now, how can we use pointer to iterate over all the elements of this array? So as we know that it should be a pointer to a row. So that means it should be a pointer to an array. So we should use something like this, a declaration int star q of 3. So this is a declaration, and we have a parenthesis around the star q, which tells you it is a pointer to an array of 3 integers. Now if we do some q equal to b, so q equal to b, now q contains the starting address of the first row. So we'll just printf percentage p and percentage p. Just do some operations on q plus 1 and q plus 2. So q plus 1 is a pointer. Now the pointer, because it's a pointer to an array of size 3. When we do q plus 1, it will point to the second row, and q plus 2 points to the third row. You can see here 40 and 40c, because there are 3 integers and each requires 4 bytes. 12 total 12, 40c and then 58. And so to access the individual elements, again we can use star q and star q plus 1 gives the address of the second element. Address of the star q plus 1 gives the address of the second element in first row, so on. It is similar to whatever the way that we did for star b plus 1 and then accessing that element. Okay, and there is another way also we can iterate over a two-dimensional array by using pointers, is by declaring array of pointers. Now we can have a pointer for every row. Like that we can have an array of pointers. So here we have 3 rows. Then we should declare array of 3 pointers. Suppose if we have int 4 int d of 4 4 2, then we should use here int star s of 4. There will be 4 pointers, and each pointer is pointing to a row, and we can say something like this: star b is now contain the starting address of the first row, and as we know that b plus 1 gives the starting address of the second row, and star b plus 1 gives the starting address of the second row, and then we can access those like a normal pointer star p, because here each element of s is like a normal pointer, and we can access the elements. Now in both cases, if you observe in both cases, whether it is int star q of 3 or int star of s of 3, we need to specify, in the first case we need to specify how many elements are there in a row. In the second case we need to specify how many rows are there. Now to avoid these, what we can do is we can use a pointer to a pointer, like int star star r. So int star star r, and then you can declare some number of pointers, and then with the dereferencing you can access. So the point here is, if a pointer to pointer having a starting address of two-dimensional array, you can access all the elements by thinking like that star rr as a array of pointers, where the number of pointers can be specified at a runtime. So that is something that we will see in the next class. That is, there are two important observations here. One is int star p is when you have starting address of an array, we can access all the elements of that array. That means we can allocate some block of memory, and then the starting address can be stored into p, so that we can access all the elements of that array. Similarly, when we write int star star r, if r, some block of memory is allocated for a two-dimensional array, if that starting address can be stored into r, and thinking like it is an array of pointers, where the number of pointers can be specified at a runtime, we can access all the elements of that two-dimensional array. This is something that we will see in the next lecture of the dynamic memory allocation. Thank you.